In this new unit, we're going to be looking at something called exchanging data. We're learning about encryption, hashing, compression, and all about web technologies as well. We're starting this unit looking at compression, encryption, and hashing, particularly first of all at compression. Our key questions today are: what is compression and why do we compress? So compression is the reduction in volume of data. Think about it in science, the reduction of volume in anything. But in computer science, it's exactly the same. Data compression is where we reduce or remove any data that's unwanted, so it's a smaller size than it originally was. This saves us space in memory. On a computer, the purpose of compression is to reduce the file size, so it takes up less space, or it minimises the transfer rate of data which is streamed over the internet. As we improve the quality of data, that means we have significantly more data to send over the internet. And compression, remember, allows us to make this smaller. There are two types of compression: lossy and lossless. Here you can see an example of lossy compression. You can see the original image on the left-hand side, which is 12 kilobytes, and a compressed image which has gone right down to 0.5 of a kilobyte. Lossy compression works by removing non-essential information. An algorithm is used to strip out all this data, and you often see it in multimedia files and images. The problem with this is, as you strip this data off, sometimes the quality can be compromised. Once that data has been deleted, it cannot be restored. So think about telephone or mobile calls. They use lossy compression. When you're on a call, it's clear what the person is saying, but sometimes the quality can be quite poor. Think of when you're talking to somebody on WhatsApp or Snapchat. All of a sudden, the quality can go down, but you can still hear what the other person is saying. This is using compression. Songs often do the same. The algorithm actually looks for frequencies in the song which only humans can hear and then removes them. It's similar for sounds as well, and images, where you don't need that data. You can see on the sound spectrum that actually certain frequencies are not needed in the song. So if you look at the different hertz, at the top of the range, you'd see bats and dogs can hear this sound, but unfortunately you can't. So we can remove that now. Here's an example of lossy compression. To make the file size smaller, we can reduce the number of colours in the image, or we can store larger areas as one colour. You can see the reduction in quality as we've done this. Here's another example of lossy compression. Remember that data is permanently removed, so if you try to reconstruct the image, you wouldn't be able to do it, but it would be a much smaller file size and good for use on the internet. And finally, a really high quality image here. If you reduce it significantly, you can see the difference in file size, and actually if you reduce it to a certain level, sometimes it's hard to tell. Again, this would be a perfect reduction to use on the internet. So in summary, compression is the reduction of size of a file. Lossy is used in multimedia, where data is removed via an algorithm and cannot be reused. Lossless is the second type of compression and works in a different way. Rather than removing data, it looks for patterns in the data instead. Using these patterns, it can then encode them and they can be reassembled at the other side. So you're not losing any data. If you look at the quote here, think about the repeating words. What could be compressed and how could this be compressed? Here we have the repeating words. We could give them all a number and then just repeat the numbers. In a film, we'll often see 24 frames per second. The algorithm will often assess that the actual background stages are the same in each of those frames, but only certain things are required to move, and this can be encoded. So typically, lossy achieves a much smaller file size. That's because the data is removed. However, in certain situations, we can't just delete data. When you're making a program, we can't delete blocks of code. And so in these circumstances, you'd need to use lossless. So remember, lossless compression doesn't lose any data. Here's an example of an image. It finds areas of the same colour, and rather than recording them for each pixel, would record them as 15 blue pixels, rather than blue pixel 15 times. Here you can see the binary code for that. Imagine the first binary code is blue, and that would be repeated 15 times. We can actually just say how many times we want it to be repeated. So in this instance, it would be 8 times, because the first binary number is 8, and then the colour we want to be repeated. Here's a task for you. Assuming the first 3 bits are the colour, and the next 4 bits are the number of pixels of that colour, can you encode the first 2 lines of this image? Count up the number of uncompressed total bits and the number with lossless compression. So in summary, compression is the reduction of a file size. We do this by compressing using either lossy or lossless compression. The idea is to reduce download times on a computer or load times and amount of processing that is needed. Over the internet, this will make better use of any bandwidth that we have. Remember, lossy compression is often used in multimedia, where parts of data is permanently removed from an algorithm. This means it can't be restored. Whereas lossless data is data which is encoded in such a way that the file size is reduced, and it can be recreated exactly. But it's often not as small